Hey everybody, welcome back. In this short video, we're going to talk about radiation sources. All radiation sources fit into these two categories: natural radiation and what we call anthropogenic radiation, which just means man-made. The 50% that you see on each side represents the total radiation dose received by the average person in the United States. So, of the radiation dose received by the average person, about 50% of that radiation dose comes from natural radiation, and the remaining half, the remaining 50%, comes from anthropogenic sources. So what are those specific sources? On the natural side, by far the predominant radiation source is radon gas. Radon gas leaks up out of the ground, gets into people's homes, and is received by individuals as a radiation dose. The next most common natural radiation source is space radiation, which is only about 5% of the total radiation dose. And also internal radiation. So what we're talking about is like when people eat foods that have radiation inside of it. Classic example of this is bananas. Bananas include a significant amount of potassium, and some atoms of potassium are actually radioactive. So you eat a banana or other types of radioactive foods, you actually get a very, very small radiation dose. And then we also have other terrestrial sources. Okay, so now on the anthropogenic side, about 50% of our radiation dose to the average person comes from man-made anthropogenic sources. By far, the most common comes from computed tomography, about 24% to the average person. After that is nuclear medicine, 12%. Then interventional radiography, which is 7%. Then fluoroscopy, about 5%. Then consumer products that include radiation, like, for example, smoke detectors have a tiny amount of radiation in them. There's other devices that have very, very small doses of radiation that we absorb on a daily basis. Occupational radiation dose, so that's referring to like people like you and I who work in diagnostic imaging. And then finally, industrial sources of radiation, like people who live close to nuclear power plants. Notice how in this graph, by far, the most common source, the largest dose of radiation, comes from radon gas at 37%. But then also notice how on the man-made side, on the anthropogenic side, the largest categories belong to diagnostic imaging. So if diagnostic imaging wasn't a thing, if we didn't have computed tomography and all these other things, then there wouldn't hardly be any man-made dose. So most of the man-made dose comes from procedures performed on people in diagnostic imaging. When you think about the dose we get from man-made radiation, a lot of people would immediately think of like nuclear power plants. So you would imagine that living next to a nuclear power plant and all the radiation inside of those, that you'd get a big dose. But you actually don't. You get much more dose from medical imaging procedures. So these are our two large categories: natural and man-made, and the individual divisions inside of them. So let's talk about some of these categories in more detail. As we're discussing the natural sources of radiation, it can be divided into its own categories, and one of those categories is what we call terrestrial sources. Terrestrial just means from the earth. That's all terrestrial radiation is. Radiation from the ground, and again, that's mostly from radon gas. So the amount of dose that a person receives from radiation in the ground is almost totally dependent on their exposure to radon gas, and that depends on the soil type. So there are certain types of soil that just have a higher potential for radon gas, and that depends on your geographical location. So when you look at this map of the United States, the different colors represent the different concentration of radon potential based on the soil type. So I'm here in Missouri, and most of Missouri is green, which means there's a moderate or somewhat variable amount of radon gas concentration in the soil. There are some areas where the potential for radon gas exposure is very low. So look at the Gulf Coast and the lower East Coast. This is what we would call the coastal plains. And the soil type in those areas has very, very little radon potential. The highest radon potential is in blue, and those are generally northern areas and areas that are mountainous. So those soil types have the highest level of elements like uranium and other elements that ultimately decay into radon and becomes a gas that can get into your home. So mountainous areas produce the highest potential of terrestrial radiation dose. Another category of natural radiation is cosmogenic sources. So cosmogenic sources is just radiation that comes from space. It's not coming from Earth, it's coming from space and mostly from the sun. Sometimes it's called space radiation because it includes radiation dose from the sun, but also other objects in space like stars, and several things in space can actually produce radiation that ultimately gets into our atmosphere and into Earth. The space radiation dose that is received by the average person is completely dependent on your altitude. And that actually makes a lot of sense. The closer you are to space, the more dose you get from space. So areas of very high altitude have the largest dose from cosmogenic sources. So let's see how well you understand this material. Answer this question. Considering both terrestrial and cosmogenic radiation, what locations in the United States receive the most natural background radiation? This background radiation is the things that we've been talking about, the radiation that we're exposed to just as a part of life. So if you're considering natural background from the Earth and natural background from space, what location in the United States will have the highest natural background radiation? Take a second to try to examine the material we've talked about and answer this on your own. So the correct answer for this question is going to be those mountainous areas, because mountainous areas meet both qualifications. Mountainous areas have very high levels of terrestrial radiation, so there's radon gas coming up out of the ground, more so there than in other places. And then also mountainous areas, of course, have a higher altitude, so you're closer to the sun, closer out to space, and so you're getting more space radiation in mountainous areas as well. So that's a simple lesson. Let me know if you guys have any questions. Thanks.